So finally, let's talk about trust, one of my favorite topics, or rather, how you can move beyond it. In this demo, we'll show how Super Protocol replaces blind trust with built-in cryptographic proofs. Every run is verifiable, independently and transparently, down all the way to the hardware level. So trustless doesn't mean insecure, it means verifiable by design. Because every workload produces a cryptographic proof showing what ran, where and how without exposing the actual workload data. Now let's see what makes this truly trustless. Full verifiability and trust aren't required anymore. When a workload runs on Super Protocol, it generates a cryptographic attestation, a signed proof from the hardware itself, building on the attestation capabilities inherent in confidential computing. This attestation verifies that your model executed in a real trusted execution environment, a TEE, using unmodified code on verified hardware inside a secure open source runtime. You don't have to trust the provider. You don't have to trust the platform because you can verify, and even if you don't, the system won't expose your sensitive data if there are attempts to bypass it, simply because the protocol won't allow your application and data to load and run if this happens. Here's what that looks like in practice.
Hi, today we'll demo how Super Protocol helps data owners and AI model developers collaborate securely. One of the toughest business and technical challenges is training models on medical data, where privacy is crucial. We'll show how Super Protocol solves this. We have 3 participants: Alice's lab, Bob's clinic, and Carol's research center. Alice and Bob each hold sensitive data sets. Carol brings a training engine. There's no model yet. The goal is to train a brand new model for early cancer detection on Alice's and Bob's data without exposing either the data or Carol's intellectual property. All 3 inputs, Alice's data, Bob's data, Carol's training engine, run inside a trusted execution environment, or TEE. No one, not the cloud host, not Super Protocol, not even the participants, can access what's inside. Outside the TEE, each party keeps full custody of its assets. Inside, no one can see raw data, source code, or weights. Training is fully automated by the verified engine, the Super Protocol Certification Center, and smart contracts on OptBNB, BNB Chains Layer 2. In the past, multi-party training meant legal paperwork, manual setup, and blind trust. So many projects stalled or took months or years to get underway. Super Protocol removes those trust barriers. It hides the complexity and automates the entire process behind the scenes. And you don't need to be an expert in confidential computing. At Super Protocol, a confidential virtual machine, or CVM, is launched once and then handles multiple jobs. No need to spin up a new VM for every task. On boot, the CVM contacts the Open Source Certification Authority, also running in confidential mode for remote attestation. If the check passes, the center issues a certificate proving the CVM is genuine and running inside an attested trusted execution environment. But attesting the CVM isn't enough. Before any data enters, an open source security mechanism inside CVM, the trusted loader, comes in. First, it's attested and gets its own certificate. Then it creates a signed key pair and checks every component. If any of these checks fails, the process automatically stops to safeguard all parties and ensure nobody's data or models are compromised. Now, let's walk through that flow. Carol builds a container-based training engine. Here is its hash. She uploads her engine image to her own encrypted storage, provides its hash and the source code so that the data owners can verify them. Alice and Bob check them. To be clear, Carol's engine is proprietary, but she privately shares its source code with Alice and Bob so they can verify it doesn't leak data. If she's not happy doing this, or if Alice and Bob aren't security experts, an alternative is to have an external party inspect it and provide assurances to Alice and Bob that the model is safe to process their data. Meanwhile, Super Protocol's open source certification center lets anyone confirm that the whole process runs inside a trusted confidential environment. Alice and Bob archive and upload their datasets using the Super Protocol CLI tool called SPCTL. The utility encrypts the files during upload. Bob uploads his dataset to his own decentralized storage. Alice uploads data on her side to her storage. Let's see what's inside Alice's file. Here is the hash, encryption key, and storage access. The same will be with Bob's file. Alice and Bob grant the CVM access and specify the verified engine's hash and the ID of the confidential virtual machine that will process the order. In our case, it's the compute offer number 8. Its public key is already published on the blockchain. Even Alice herself doesn't have access to this encrypted data, as only the specified CVM with ID 8 has the private key to decrypt it. Bob's data is protected in the same way. Carol places the main order to process the workload, using her uploaded engine and Alice's and Bob's prepared access files. She uses the compute offer 8. When the job is submitted, the trusted loader checks the CVM certificate, calculates hashes for the engine, datasets, and config, compares them with the approved list, blocks the job if anything diverges. Only if every hash matches does training start inside the TEE. Data and the engine are only ever decrypted inside the TEE. Even the participants cannot access them during execution, and everything is protected from other parties, including the owner of the system executing the training. Only Carol receives the encrypted output, the newly trained model and artifacts. Encryption keys never leave the TEE, so Alice, Bob, Super Protocol, and the hardware vendor remain blind to the results. Let's check the order's status. As we can see, the job is already done, so we can download the result now. Here it is, and we can also see that it was decrypted. SPCTL decrypts it using Carol's key specified in the config file. You can find more details about this process in the Super Protocol documentation. Everything is explained there. Let's unpack the result and check what's inside. The logs show that the application ran as expected. We can see files located in the input directories, meaning the input and reference data were pulled from those directories, just as expected. Then the training process ran, and the results were saved. All output was successfully written into the SP output folder. Here's the trained model, the PKL file with its weights, evaluation matrix, and other output artifacts. All of this was processed in a fully confidential environment. That means everything ran on a secure machine. Security is great. Proof is better. Before training begins, the trusted loader creates an integrity report signed inside the TEE. That report is later published on OpBnB as the part of order report, giving anyone public, tamper-proof evidence that the job will run in a certified environment with the approved inputs. Here's how we retrieve the report for this specific order using the SPCTL command. If the job has already started, this report has already been published to the blockchain. What we see here includes the certificates we discussed earlier, along with a list of processed inputs and the timing. The image refers to the actual executable workload. Its hash matches exactly the one we saw earlier, the one trusted by both Alice and Bob. Right here, same hash. We can also verify that these hashes correspond to Alice's and Bob's inputs. Let's take Alice's dataset. Its hash matches. And now Bob's. Same thing. So yes, both Alice's and Bob's data were used in this job, and it ran with the correct training engine. The job is complete. The result is encrypted and delivered only to Carol. After every job is finished, all raw inputs are wiped. An order report is published on chain, giving everyone public proof that the run was genuine. The order report isn't just an audit log. During runtime, an app inside a CVM can sign data with its private key, Anyone on-chain can verify that the signature came from a trusted, decentralized, confidential environment, crucial for Web3 AI workflows. You've just seen how Super Protocol lets Alice, Bob, and Carol train a medical AI without ever exposing data or models to each other or any other parties. Super Protocol turns complex, multi-party, trust-heavy collaboration into a push-button workflow. Try it yourself. Build, verify, run, no expertise in confidential computing required. Thanks for watching.